Moving on in the third sample test. This next problem, number 3, says find the absolute extrema on each interval from f of x equals 10x minus 1. First thing we want to do is find any critical values. So I'm going to find f prime of x. Here the -1 goes to 0, the 10x goes to 10. What this really tells me is that there are no critical values. There's no way to set 10 equal to 0, there's no value of x which would make it 0. Really, the interesting thing about this 10 is that it's positive, which tells me that this is going to be increasing everywhere. So when I go to find absolute extrema, I really only need to plug in the endpoints. There aren't any critical numbers in between I need to worry about. So here, if I plug in f of 0, that becomes 10 times 0 minus 1, which is -1. If I plug in 5, that becomes 10 times 5 minus 1, which is 49. This is my absolute min. This is my absolute max. Specifically, this is occurring at the point x equals 0, y equals -1. And this is occurring at the point x equals 5, y equals 49. Really, those are the only two things that I have to worry about as I go through and do parts B, C, and D of this problem. The only thing I have to consider is if it's a parentheses, then it no longer exists as a limit. So here, when I go to do part B, f of 0 is still the same. 0 is bracketed, so it's included. So f of 0 still gives me -1, which is an absolute min, and it occurs at 0, -1. But now I can include 5 as an endpoint because of the parentheses. For that reason, the absolute max does not exist. It's flipped here in part C. In part C, the absolute min does not exist, but the absolute max is found from f of 5 equals 49, meaning my absolute max is the point 5, 49. For the final one, they're both parentheses. Since they're both parentheses, neither one exists. So both for absolute min and absolute max, I'm going to write D and E. All of this could change slightly if there was a critical number. If this had given me something I could set equal to 0, then I'd have to be testing that in each one, and it might be that these absolute mins or maxes could exist even with the parentheses. For problem 4, it asked me to find the 2x intercepts, then show that f prime of x equals 0 at some point between the 2x intercepts. This is really asking me to use Rolle's theorem. So the first thing I'm going to do is I'm going to factor f of x. This becomes parentheses x minus 6, x plus 3. Once I have it in factored form, I need to say what makes each of these equations 0. If I plug in x equals 6, that's what makes this 0. If I plug in x equals -3, that's what makes this 0. So I have 6 and -3 as my 2x values for my intercepts. 6 and -3. I then just need to put 0 as the y value to complete the coordinates of those two intercepts. Last thing I need to do is find the c guaranteed by Rolle. The way that I'm going to do it is I'm going to take the derivative of the original equation. When I take that derivative, f prime of x, x squared becomes 2x, -3x becomes -3, and the -18 goes to 0. So I'm left with the derivative equals 2x minus 3. If I set that equal to 0, I can add 3 to both sides and get 2x equals 3, which means that x really equals 3/2. So if I'm looking for the x value guaranteed by the theorem, x equals 3/2 or 1.5.